Am I audible now? Much better. Always good to test these things before continuing. All right then. So let's get into it. Last time we had just finished up adding static scoping to a bunch of things. And we're realizing that this would cause a whole big bunch of tests to fail. And those would need to be fixed, and that the evaluator wouldn't work, and all kinds of stuff. So let's try building the project again. I want to see if Flexor test. Okay. We should be doing parse top instead. There we go. All right. Now that we've done this, let's just see what happens. Huh. Well, that's not very auspicious, is it? What happens? We do this. Pull this error out. Indeed, it, it oh, oh, I know why it's failing. This is really obnoxious. Um, we have more keywords. No, no, no. Oh, you silly thing. I should rename this file. It's not really Lexer test anymore. But what are our keywords? Tokens. That's right. We care about our tokens. If, else, while, var. So that should help to some extent. If, else, while, var. And here we are just printing stuff out, so we don't care. Um, we didn't add a new category of token. So we don't need to worry about that. We just added the var as a keyword and while since last we visited Lexer test over here. All right. Now let's see what happens. All right then. We in fact successfully failed. Not see. Let's see if this fails. Identifier foo not found. Exactly. All right. There was a parse error. Got it. So all of this bodes pretty well for things actually working. Um, I just need to fix the evaluator and everything else now to have the proper thing. So this is basically just a test. Can it actually parse a program properly? Like this is a well-formed program. It declares the variable before it uses it. If I really wanted to be a lot more complicated about it, I could do this. Let's see what happens with that. Yep. couldn't parse bouncy. But it looks like the only bouncy that it couldn't parse was the second one. Let's try this one more time. These are basically some ersatz tests of yep. So looking at this parse tree, like all of this works, but somehow it failed at this point in the parse tree. I don't know why it returned what it returned. I would have expected it to return an empty parse tree in this particular case. Maybe I should have a test for that. But it's reasonably clear that it succeeded in parsing everything until it got to uh, the I equals bouncy part, which is good. So using bouncy here worked. So basically the scoping worked great. So I am a little tired. Because, yeah, it's testing to make sure that bouncy worked inside of here and that bouncy did not work uh, here. In fact, I'm betting as a further test that I can do this and just not have the last line and everything would work great. Yep. So basically the thing that causes the error messages to be printed out is that last line where it says bouncy equals bouncy plus I. Or no, I equals bouncy. This line right there is the one that causes all the error messages, which is exactly what's supposed to happen. Bouncy should work just fine in here. All right. So oh, I thought of something that's missing. I thought of something that's missing. So variable declaration here. What does it add when there's first of all, what? Okay, that's what I. Why are there differences? I thought I committed in parser. Apparently, I made a bunch of small changes to parser after. What's this? Okay, there's a whole big bunch of changes that I made here that didn't get committed. Add new keywords to debug output in lexertest.cpp. Um, I don't know how those got added in this way. This extra space makes no sense. All of these things should just be equals delete like that. And I don't know why the extra spaces got put in. And there needs to be a space here and a space there. All right, it put in a bunch of extra blank lines, which that's fine. There should be an extra bunch of extra blank lines. I want those blank lines there. I don't know why they weren't there before, but just keying right in there. All right. Tests not updated and okay. And I'm going to push these up to GitHub because I've been forgetting to do a whole big bunch of that. And there needs to be, yes, GitHub needs to be have more stuff up there. Huh. Why does it think we're using Git? I don't know. We're not using Git. We don't even have a .github. We have .hg. There's a Git. We don't even have a .git directory. In the hg directory, there's a .git directory, but I don't know. I'm really curious as to why this is showing up, even though, first of all, but if we do cd then git, oh, I bet. Yeah, I bet it's like CTRE. Yeah, it's it's catch two. That's the problem. Okay, it's complaining about a subrepository, which is fine. I fix it's a subrepository, right? So I fixed it at a tag because I'm not actually editing the subrepository. It's a read-only thing that I have here, and so it doesn't really matter that it's a detached head. It's the whole point. Um, and here, this is also a subrepository. It just also so happens that the tag is where last I pulled this tag that I have it fixed to also happens to be where main is as well. Um, and if we cat Daishi substate, we'll see that in fact Mercurial is keeping that fixed there. Um, all right, that's why that's there. Just distracting from real issues at this point. I just you know it's complaining at me. What's it complaining about? Um, doesn't like this. Huh. Well, that's interesting. Using clang D, it doesn't like that. Um, all right. Now it's time to go through our to-dos and actually implement the things that we just punted out. Oh, no, no, no. I had a thing where I was going into the variable declaration to figure out what it was doing. Parse vardecal. So what's it do here? So I'm expecting here parse expression. What do I do with this expression? Ah, it does in fact appear as an AST node. Um, I don't know that it should. I don't know that it should. Okay. The reason I was thinking about this is I was thinking, okay, well, in schemish syntax or Lisp-ish syntax, all these var decals would basically be a big let statement. The problem is that's only true if the var decals are all together. Like you could have a couple of var decals and then a bunch of stuff and then another var decal, and the bunch of stuff could modify the values of the variables, and then the let statement down below, yeah, it would be it would have to appear down below as a further let statement, um, effectively introducing another block. But in this language, no other block is actually introduced there. Uh, yeah. And I was wondering, well, could I just have a block at the beginning that lists what all the variables are, but then what are their initial values? The let statement requires that everything be given an initial value. I was just thinking about the implementation of the prefix, the the prefix operator here, the prefix printer to prefix string, the prefix stringizer visitor, which is one of the things I have to implement. So we're going to go through and look up all the to-dos, which are helpfully, what are the orange things up here? Orange looks a lot better, worse than green. I'm just, again, the alias SV is never used. Oh, that's true. This is used. Uh, this is not used. I'll remove it. Uh, this is a non-issue. It compiles just fine with the compiler that I'm using. Clang just doesn't like it. And so it's giving an error here. And I don't know how to configure the project to not use Clang. So we'll just not worry about it. Um, there, remove unused alias. All right. You know, I ought to have a thing for keywords as well here. And it's inventing keywords. Uh, all right. Stringizer. Oh, no, I don't need that because by the time I get here, the keywords have basically disappeared. all the keywords result in the only the keywords result in new nodes of various kinds, all of them. Whereas the operators, I mean, also result in new nodes, but the nodes are things like binop, and the binop node actually knows which operator it is, and so there we care about all the operator names. So we don't care here. I actually need to make a string conversion to string for tokens in tokens.hpp, a canonical conversion to string. Or, yes, the reason why I need a canonical conversion to string for tokens is because I want to be able to print them out inside of tests. When tests fail, I want to print out what token the test failed on, which element in the array. And currently the tests can't do that. Can't print out the contents of the arrays that have the mismatching elements properly because they can't print out the individual token elements of the array because there's no default output operator, no default way to turn them into strings. So that is a thing I need to fix. Unexpected operator. Okay, so we're just going to go through all the to-dos now because we've looked at the other things that are in here and fixed them. Um, and I don't know what that is about. Oh, that's showing me where places where this was found. So basically turn this off and that goes away. Okay, there we go. So to do, update this to work properly. This is the thing to print out an identifier in Simple Evaluator. Um, Evaluating an identifier shouldn't result in any change to the current result. No, it should. Okay. We are going to punt on this because this one is, in fact, probably the most complicated to implement. Because we should be implementing the vardecal one first. And actually, even before that, we should be implementing Simple Evaluator so that Simple Evaluator knows what to do with the stack. Now we need to look at parser.hpp. Let's see if Simple Evaluator is in here. I can't remember whether it is or whether it's declared. Yes, it is in here. So here we do have stack frames. Um, my stack frame is in fact a bad stack frame. I shouldn't be having this as a stack frame. What should I have as a stack frame? Um, why should this not be the stack frame? Because we aren't actually looking up identifiers this way anymore. Um, okay. We shouldn't ever be calling a knit stack. We shouldn't be doing this. We shouldn't have an init stack. Our stack frames should not be, they should be okay. So our stack frames should be pairs of statement lists for the that describe the stack frame along with a vector of uh, values for that particular statement list. Um, that's what a stack frame should consist of. Uh, Here's what I'm going to do. That's not context and then var values. And there we go. I could put in values in here. In fact, I should, because vector does have a default constructor, and so there's going to be something in here about that anyway. And so here, stack frame T is just going to be the context for the stack frame. So the context is how the values will be interpreted. This context is pointing at the statement list. The statement list knows which name refer to which slots. And then the vector is basically just a bunch of slots. Right? It's the it's the all the values, the slots containing the variable values. And if we look at assignment statement up here, um, or statement list up here, we have variable declarations, right? And so these variable declarations, the slot number tells you it's a bunch of strings, and the slot number tells you what the name of the variable in that slot is. And so vector is basically just a list of all of our slots again, but what the names are. And here, down here, for the actual stack frame that exists at runtime, what we're going to have is all the values, which are runtime things. Variables have values at runtime, and it's going to be basically a parallel vector of values. And then the context is a reference to where to look the names up, because the names will also be in a vector of slots. But the names don't ever change, right? For every statement, list, the list of names are going to be the same because that's what static scoping is all about. You have a bunch of variable declarations inside of a statement list, and all those variable declarations list out what the slots are for the variables in that statement list. So that's how that's going to work. Okay, now that we know what a stack frame looks like, I can implement some stuff. Um, First of all, simple evaluator statement list. Uh, First thing we do in statement list is we push something onto our stack. Oh, when we encounter an identifier, it's going to know what statement list it's part of, what statement list the identifier is referencing, appeared in. Oh, this is going to be very interesting. Um, that's not going to be. So I'm trying to decide whether I should be uh, if stack. No, I don't need to do this. Because it's just fine for the stack to not have anything on it. If an identifier appears, there should be a stack frame that had a non-zero statement list already, a non-zero. If the list of variable declarations was not empty, and stack dot in place back, and then address this, comma, we'll initially put an empty vector. Let's look at the vector. Let's look at the vector constructors. There might be a vector constructor that's tailor-made for this. Because we need to construct a vector that it reserves the correct number of slots. Actually, we don't even want it to reserve. This will be a little bit of extra, space efficient dynamic bit set. This was a huge mistake that the standard library made. But they thought they were being clever at the time. So let's look at the constructors. Count value. Yes. So that's what we want. We want the count value version of the vector. Oh, you stupid thing, and your focus follows mouse, not understanding. I had somebody from JetBrains watching my stream a while back, and a long time ago, about a couple years ago, and they gave me some free keys. I really wish they were watching now because this frustration is annoying. I really wish they would fix this bug. I should file the bug on JetBrains. There's a few bugs I should file on JetBrains. This is one of them. So, yep, that's exactly what I want. Oh, no, I don't want address of this. I want address of SL. There we go. And we don't want this, that. What does it not like about this? Oh. So in place back, should call the constructor for stack frame, right? Oh, hello there, Sky. Ah. I realize that Twitch doesn't work for you. Oh, actually, no, you're from Twitch. Huh, that's interesting. You don't show up as a member of the channel on Twitch. How interesting. Let's look at here. Hmm, interesting. So I'm using two different ways of looking at Twitch chat, and one way of looking at Twitch chat, which is an IRC channel, I was using because it will tell me when people start watching, even if they don't say anything. And uh, it doesn't have you listed, which is sort of interesting. Anyway, I won't worry about that now. I'm here trying to figure out why this is not working the way I expect it to. So in place back should call, the way in place back works is it should call the constructor for the thing that's being in placed. Um, okay, I see. That does work. How ugly. Getting it all to fit like that. So basically what we do here is if we start a statement list, if we enter a statement list that has a non-zero set of variable declarations, it has some variable declarations that are part of that statement block, then we push a stack frame onto the stack. And that stack frame references this as the context for the stack. Like, what scope is this stack referring to? It's referring to this scope right here. And then it's a list of variable values that are all initialized to zero, just because they don't have to be initialized to anything. The way our language works is variable declarations always give variables initial values, but the we also the way the parser works is the statement every time a variable declaration happens, the statement list associated with that variable uh, is updated with a new identifier name and a new, just a new identifier name. Uh, and that identifier name is associated, it's in a vector, and its position in the vector is the slot number for that variable within that context. So that means that every stack, every statement list knows how many variables will ever be used inside that statement list, even before they're declared. Um, and so it knows how many slots are needed. And that's what this is doing. It's just creating the slots, the spaces to hold the values. And uh, yes, this places to hold the values. And so then at execution time, we need the spaces to hold the values, right? At compile time, while we're actually doing the parsing, we just need to know what slots each identifier is associated with, which is what the information that's in here. Now, the reason why we care about the context here is because identifiers know which context they're for. That's part of the identifier name here, part of what the identifier is about. Uh, the data that's in the identifier. The identifier knows what context it was declared in, and it also knows what its slot number is. And so in order for it to match itself with the stuff that's on the stack needs to know for each stack frame which context that stack frame is for. So then when an identifier is encountered, it can search back through the stack frames to find the stack frame that refers to the context in which it was declared. All right then. That is not the most efficient way to handle this problem, but you can fix that later. Right now, the job is to get now. All the variable values disappear. Now, this pairing here really ought to be put. This there should be some kind of resource allocation, or resource allocation is initialization, or resource acquisition is initialization. This should be a constructor. All this should be a constructor, and this should be a destructor um, for some kind of thing that, uh, yeah. So then when this block is entered and when this block is left, uh, the all instances in which this block is left result in the stack being popped. But we're also going to have an assert here that the stack is not empty. Asserts are for things that must be true by the rules of the internal logic of the program states that this must be true at this point in time. And the assert is there to catch cases in which a mistake was made, and so it isn't true. And then the program should abort at that point. Asserts do disappear in release mode. And so they're a debug mode only thing. Um, Now, in release mode, maybe you want to have some kind of defensive programming thing here. So this won't cause undefined behavior because that's what will end up happening. Um, but yeah, okay. Now, now we're getting into having R values and L values, which are a C++ or a C idea and a C++ idea. And I don't know what I should do here because uh, there are indeed L values. Uh, Assignment statement here, for example, has an identifier. Do I want to call the parse simple evaluator for identifier? But if I do that, then identifier can't just put a value in the current result. It has to uh, it has to put in a reference to the found identifier slot uh, somewhere, and the found identifier slot is the uh, C++ equivalent, or the equivalent of the CL value. Um, Current result is the R value. Oh, there. Now you're appearing as a person in the channel on IRC. I got these new headphones. I'm not used to the mute button yet. The mute button. Should have pressed that before I coughed. I don't think I'm going to deal with R values at this point in time, or L values at this point in time. And since I'm not going to deal with L values, that does mean I'm here in operator blah, blah, blah. For statement list, no. In assignment statement here, I'm going to have to do something a little bit different. Because assignment statement, the identifier is going to be assigned to. So that also means that simple evaluator is going to need a function to this private section that hasn't been used up until now. No, stack frame T pointer not find context. Just a bit. I have to do something because I need to keep the toast from popping up. No more toast. There. Assignment statement. Okay. Now, does statement list in fact have, I should probably be using whatever it is from statement list if I have it, the var edX, yes. There we go. Find identifier. All right. indeed. Oh, this should have been in the private section. There. That was a silly mistake. Equals find identifier and then as.identifier. Now assignment statements know what their identifier is. And yep, they contain a copy of their identifier, not a reference to the identifier. Yes. Partly because the only way we have is referencing by AST pointer. Yeah. So statement list assignment statement. So standard visit. This as expression. Then we do no, that is not what we do. There we go. That's the right thing to be doing. Hey. Oh. Okay. Dash greater than context. No, we don't care about the context. What we care about is the there we go. So we find the slot and we stuff in the current result. And we set the current result to 0. There we go. Now what I could have done is just have find identifier return a reference to the slot in which the identifier is in. I could have done that. Oh. Yeah, I could have done that. I didn't. And I'm okay with that decision. I think. Am I okay with that decision? We'll see. We'll see if I'm okay with that decision. All right. So now we have our next to do. We have var decal, which is just fine. In this particular context, a var decal is basically the same as an assignment statement. Var decal is, yeah, it's the same as an assignment statement. Just like, yep, exactly the same. And that also means I can fix this to be all right. Um, and vardekel, vardekel, vardekel. Vardekel, vardekel, vardekel. Yes, since it's the same as an assignment statement, I'm almost tempted to call the assignment statement one, but we'll just do this. Right, and then we'll say that yep, just like that. The variable values, find the slot, set the slot to the current result. Okay. I don't know that there's a lot of value in having a separate vardekel. On the other hand, one of the things it does do, yeah, I'll keep the separate vardekel AST node for now. Um, I think that that optimization is perhaps premature, and there might be other reasons I want the vardekel that I'm not aware of in the future as a separate AST node. But um, there we go. Infix stringizer. Now, this is actually, I'm just realizing there's a way I could have implemented the stack frame that's probably a lot more efficient uh, because it will involve many fewer allocations. Uh, but I'm not going to do it. I'm not going to do it. But I could. uh, yes, I could do it, but I'm not going to. The idea is it's a stack, right? So why not here? I'm all declaring my stack frame here. All of these var values. Why do I have that in the stack frame? Why not just have an offset into a stack for the values? And then I also have a single vector for the entire thing of variable values. Um, and I just use that. I push on, I expand the set of variable values by the appropriate thing, and then contract it again when the stack is popped. So then there's only one spot in memory where all of these things are allocated um, instead of a whole big bunch of allocations every time a new stack frame is entered. Because this basically allocates all the slots, a whole new set of slots every time the stack frame is entered. And then those slots go away, they're freed again when it's left. But if instead I just had a vector of values, that one vector of values might get reallocated as the vector was resized at some point in time. But overall, there'd be only one allocation, uh, and then this stack frame thing here would just uh, have an index that pointed into where in the big stack the particular frame for this new uh, context existed. But not going to do that because it's a little more complicated um, and only slightly more efficient. But I could do it. And yeah. So now let's see. Let's back up to this to do, because there's a to do here. This is when identifier is being evaluated as an R value. Both vardecal and assignment have the identifier as being an L value, and here it's an R value. So basically what we need to do is we need to dereference the L value to get the R value. Right? And then it got it exactly right. All right. So I'm going to set Junie to a task here just because I'm curious as to what will happen when I do that. So one of the things that hasn't been done, oh, it now is updated to work properly, I think. One of the things that hasn't been done here is the infix and postfix, infix and prefix ones. Uh, yeah, the prefix stringizer has a to do that should be updated. Um, oh, no, it has been updated. I did update. Oh, well. Uh, did I just punt on vardecal? I just punted on vardecal. uh, all right. So I did do something here. That's good. Um, oh, we're going to make current result be public. There. No, 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 no. What are you doing? There. Current result is public. All right. Let's see. Let's compile this. Oh, yes, I've not defined what find identifier looks like. Find identifier is going to be a bit of a complicated function, although it won't be that bad. So, no. Yeah, AI got way ahead of itself here. And in fact, hey, no, I put in that return on purpose. Why did you edit it out? Grr, JetBrains. Um, yes. This is fantasy. Wow. About the only thing that it's doing. Yeah, that was correct. Uh, no, 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 no. Oh, no, no, no. You're right. Now, is there a version of find? So we're looking for a version of find because we should be using find here is what we should be using. I don't know if I want to deal with uh, yeah, I think I'm going to go for standard find instead, not standard ranges find, because I don't necessarily want to deal with some of the stuff that I needed, and there's no particularly good reason to. Yes. There we go. All right. I don't even have to care whether the stack is empty here. Uh, so this will sort itself out in the asserts. I'm going to do that. And yes. Yep. Okay. Yep. That should do it. And I wanted to use standard find if here because standard find if kind of signals what it is, what the heck it is that we are doing. Um, yes. And maybe it's parallelizable. Who knows? Um, although we care about the first one that we find. So, yeah. All right. Let's try running our Lexer test again. There. And go back up through our history here for, oh my. There we go. First, of course, some of this should fail because the parse failed, but let's see what happens here. And it failed. I got a parse tree out of it. I should have, that's a thing that's wrong. I should fix that at some point in time. But, no, I got, it did the thing that it should do here. Um, I believe I got myself into an infinite loop. Well, that's nice. So I forgot to decrement I. All right. Yay! And is that correct? If we square everything, do we get that? So 25 plus 16 plus 9 plus 4 plus 1, 55. Okay, that worked. At least it appears to have worked. And so that means all kinds of lookups were happening. There should have been all these different contexts. Uh, well, that was tricky. That was tricky to implement. Um, yes. And all right. Static scoping now fully implemented. Tests will still fail. And we're going to push that to GitHub. Okay. Uh, I missed the context for the do it. So what is the what was it that I was supposed to do? And Factorio is indeed fun. So I've been at this now for probably about an hour and a half. I could continue on. The thing that I think I want to do it off stream is implement some of the pre-commit hooks for Mercurial to make sure that uh, my commit messages are are formatted to my standards, so that I will complain at me. One of the things I would like to be able to do is to uh, also override the commit hook. Tell the commit hook, yes, I know this commit message is broken. And that's fine with me this time, um, which is probably going to be a special tag within the commit message, which will look ugly, but I already don't care if it's ugly. So probably be fine. Anyway, I think that I am done for this evening with this particular task. The tests still need to be updated. That's what's going to happen next time. Is all the tests are going to be updated. Uh, oh, actually, there's one last thing I want to do. I want to ask Junie something. Uh, There. I do not know if Junie knows how to do anything with Mercurial. Basically, I wanted to ask Junie to give a summary of what its opinion was, just to see what it thinks. Um, Junie is uh, JetBrains' uh, AI agent thing. AI agents being essentially LLMs that have been hooked up to a bunch of tools that they've been taught how to use. Um, and yeah, then they use those tools and attempt to accomplish a task. And among those tools are things like, oh, the thing has to compile or the thing has to pass tests or whatever. Um, uh, anyway, now we're spending time watching the LLM talk to itself. But it is kind of interesting seeing what its plan is and what it thinks needs to be done and all of this stuff. Um, I do believe from the messages that it's displaying that it did correctly understand how I have implemented it, what I'm actually doing and why, even if the auto completion code did a terrible job of guessing. It did a great job. One of the interesting things about the way completion was working as I was typing this in general is completion was terrible. Once things reached a certain level of complexity, completion was terrible at telling me or at guessing what I was going to do when it was something that I hadn't done yet. When the program was pretty simple, completion was in fact pretty good at doing that. But as it got more complicated, completion became terrible at it. In fact, almost a hindrance. And but on the other hand, once I had done something, completion was then able to very quickly figure out what to do about it, like how to. Uh, Completion was very good at being able to detect when I was doing a thing that I had already done and putting in the version that was appropriate for this particular situation. Uh, so it was pretty good at that, which is interesting. That also means that one of the things that the completion thing is good for is the it's good for uh, telling you when you might be violating DRI because a completion can figure out what it was that you're doing. Then maybe you're just doing something you've already done before, and you should sort of refactor that out. Um, and yes, we're going to put this in an editor tab. I'm going to make this editor tab very large. Make the other editor tabs much smaller. names are bound at parse time to a specific block and slot. And the evaluator uses this binding, and it even decides, it can't hear anything I've been talking about on this stream, and it still decided that slot was the appropriate term, even though that name does not appear. I don't name anything a slot. It just decided that it's a slot. Uh, and so it realized that names are bound at parse time to a specific block, statement list, and slot, uh, variable index. And the evaluator uses this binding to find the right runtime frame. It is efficient enough for the current language surface, and it preserves shadowing semantics correctly. Yes, you can do this as efficiently in Rust, often more predictably, by replacing raw pointers with stable IDs. And if you want, switching to Brusian style indexes or pre-computed frame offsets for O1 runtime access. Now that's actually pretty interesting. And stable IDs is an interesting idea for doing it. Basically, having all of your contexts, your statement list pointers, instead of having direct pointers to them, you have some kind of big index of all of them, and then you have a pretend pointer, which is the index of the statement list in there. That's an interesting implementation technique, and I guess that's something you can do. I don't know. Uh, it doesn't really add a level of indirection because you're adding an addition. You're adding an addition whenever you're doing the lookup because you're starting with a base pointer and then you're doing an addition to find the offset into your array, and that's very cheap doing that. Uh, so it doesn't really adds much in the way of runtime cost. Uh, Um, but I don't know what Debrusian style indices for pre-computed frame offsets. So I'd have to look into what it meant by that, um, because I'm sketching out an implementation technique that kind of fits broadly what it's talking about, but it looks like there's a specific thing that it's talking about that I'm not familiar with. That's an elaboration on that implementation technique that makes it even faster, which the implementation technique that I'm talking about is in fact not particularly slow. Um, so I guess you could do it. One of the things I don't like about that is, uh, while the ID can be checked for uh, being invalid because it's off the end of the list every time you do it. So that's one thing. You can check that your index is basically becomes a pointer. But the pointer is in an array whose bounds you know. And so you can easily check whether the pointer is pointing at something that doesn't exist anymore or never existed if it's a invalid pointer. Um, and so that's makes it memory safe because you're never trying to use the pointer to get to something that isn't there. It does require that the IDs be stable, which means that you have to have some kind of data structure that allows you to add things to your list of IDs and never remove them or remove them. Yeah, that's an interesting. Again, I would feel like I need to look up this implementation technique because I suspect that the Rust people have in fact come up with solutions to these problems. And so what I implemented, compile time binding. During parsing, you maintain a block stack of statement lists. Parquet identifier walks that stack from inner to outer, finds the block that declares the name, and emits an AST identifier that stores the scope, a pointer to the statement list where where the variable was declared, and an index into the list of variable declarations made in that statement list. So basically, the slot number. This is classic static name resolution. The AST carries the binding to a particular scope and slot. Now, that's very interesting that it's classic because I, in fact, had no idea how static name resolution was implemented anywhere else. And so I came up with this all on my own. Um, yeah, and it turns out to be a classic implementation technique. Uh, it is a not overly surprising. A whole big bunch of reasonably intelligent people who encounter the same problem might all decide on a very similar kind of solution. The runtime model. Uh, on variable use, find identifier scans frames from the top down until the context. Until it finds one that's frame for the appropriate block for that variable, and then it, yes. Runtime variable adds accesses O depth of dynamic stack to match the scope. By pointer equality, that's a little pessimistic. It's usually going to find it in a fairly, people don't often reference variables. People much more often reference variables from inner scopes than they do from farther out scopes. So in practice, while it's technically O of the size of the stack, in reality, it's probably going to be something. Oh, but there's cases if the stack ever ends up being a part of a recursion thing, then the recursion thing is going to act funny. Because, like, if you refer to a global variable inside of your recursion, it's going to have to jump out through all of the stack frames in order to find it, which is kind of annoying. Um, it's going to have to search through all of them to find the one that it's looking for. Uh, Parse time identifier resolution is linear in both scope depth and the number of variables per scope. Uh, yeah, that's fine. This one is more fine than the previous one is because it's highly unlikely to have heavily nested scope, a statically nested scope. Um, and the number of identifiers in any given scope is not going to be huge. So doing linear searches is not going to be a problem. Raw pointers tie correctness to the lifetime of AST nodes and identity semantics. That is true. If I start changing around the way the AST works in a significant way, the raw pointers will fail catastrophically. Uh, and that's not such a great thing. It means that I have to be very careful to change where all the raw pointers are being used. Uh, every time I make a modification, that would affect. Um, this parse time, uh, yeah. Oh, yeah, this is silly. Uh, uh, Now, this is a silly optimization because this requires that the number of identifiers in a given scope be pretty large for it to be worthwhile at all. It would have to be in the hundreds for it to be worthwhile, and so that's pointless. The one different optimization that it didn't mention that I could make would be some kind of list of all variables visible at the current scope to make looking up a variable really quick because then you just look it up in the list of all visible variables at that scope, and then it would tell you what scope the variable was declared in, uh, and so on and so forth right away without having to walk back through a stack like I'm currently doing. That would require updating this map every time a stack frame is entered or left, uh, and that's fine. Um, yes. Runtime. Instead of searching frames by pointer equality, pre-compute an integer static depth for each identifier during parsing. Well, this doesn't work if I have recursion. Um, that's actually the better idea, is having some kind of mapping for statement lists so that I can, uh, yes. Okay. Well, that's interesting. I will copy this. Anyway, uh, I was just curious because this is non-trivial. One of the things I might do, I do not like the Rust community. I don't like the way the Rust programming language is being pushed as a kind of a purity exercise and a moral necessity in the programming community. It's being pushed for reasons that are not technical. Technical and moral are being conflated, and they never should be. Uh, Different people have different values for things, and that's as it should be. There's not a universally right value. What's really interesting is that the people most prone to telling you that morals are relative are also the ones the most prone to having purity spirals involving their own moral values. Uh, I don't understand why that's the case, um, but it is. I yeah, I I don't understand it. Uh, but a lot of the people pushing Rust see the memory safety as being a moral good, an absolute moral good that everybody should always strive for in every situation. Uh, and they see other things like political affiliation the exact same way. Um, and so they have this uh, very rigid idea of why people should have certain politics and what values are the correct values that everybody should hold, and anybody who doesn't hold them is clearly a monster of some kind. Uh, and they apply that to people who want to use anything other than Rust, the same way they apply it to people who have other political ideas or political ideas that they don't like. Um, it's something that I find very toxic about the Rust community in general. But the Rust itself is just a thing that exists and has no moral value in and of itself. It is just a programming language, and it has its technical strengths and technical weaknesses. And I should probably learn the language, regardless of the community that produced it, um, because the language it's as a thing in itself is not uh, irrevocably tied to the values of the community that produced it. Um, So I should learn it at some point in time. And this is actually interesting because it's essentially a non-trivial program and a sketch of how you might go about implementing parts of it in Rust. So that's a interesting thing to have. Um, and porting this whole language to Rust once I get it into a state where I'm done adding things to it would be an interesting exercise in learning Rust. It would be a non-trivial thing to implement in Rust, and so would teach me a lot of Rust. I might do that. Um, anyway, I am going to end the stream now. Um, I'm sorry, Fudal, that you came in just as I was finishing up. Uh, but, well, that's how it is. Uh, and I'm sorry I missed some of the other people who showed up. Um, but any questions from anybody before I end the stream? I don't know where this got stored, if it got stored anywhere. It's a thing to fiddle with the IDE to figure out. No questions? Going once, going twice. Well, I wish all of you a good remainder of your Friday, if it's Friday where you are. I think there are places in the world where it is now Saturday. So, but if it is still Friday for you, I hope that your rest of your Friday is excellent. Let's see here.